All right, so this is the lecture portion on how to calculate from percent composition, which we discussed above here in our notes, and go from percent composition to the empirical formula, which is what you're doing for your calculations of the empirical formula of your oxide lab. Now in figure 3.5 from your textbook, and this is also a component of your pre-lecture worksheet, kind of the basic mapping or plan of how you want to go from percent composition to the empirical formula. Okay. Starts out with your mass percent. Which you then calculate your moles of your element. Then to your mole ratios to the empirical formula. Now this first step, your book kind of lumps into one. Sometimes I like to separate it, but basically you're going to take your mass percentage, okay, so mass percent, change it to grams, and then change to the moles of your element. So to go from your percent mass to grams, we're going to assume that you have 100 grams. Now you can assume anything, but it's just easiest because you're in a percent to start with 100 grams. That way your percent just turns into grams. Then, as we've been discussing, to go from grams to moles, you use molar mass. Then, to complete the calculation, we go from moles of the element to the mole ratios, and that's where you're going to divide by the smallest number of moles. Then the final here is to go from your mole ratio to the empirical form, and that's just you have to have whole numbers for your mole ratios. So if we work through an example calculation of this, we want to determine the empirical formula of a compound that is 24.75% potassium, 34.77% manganese, and 40.51% oxygen. So I like to kind of keep a list over on this side for my calculations. We start with we have percents. So we have 24.75%, 34.77%, and 40.51%. The first step of this, going from mass or percent mass to grams, really easy. We're just going to say, all right, we're going to say we have 100 grams. So we have 24.75 grams of potassium, 34.77 grams of manganese, and 40.51 grams of oxygen. Now our next step, we're going to go from grams to moles using the molar mass of our individual elements. So we set up our conversions. Potassium, we want to go from grams of K to moles of K. Potassium is 39.10 grams per mole. Manganese, a transition metal, is 54.94 grams per mole. And our oxygen is 16.00 grams per 1 mole. So if we calculate these out, For potassium, we get 0.6330 moles of K. For manganese, we get 0.6329 moles. And for oxygen, we have 2.532 moles. So now for our, second to last step, we're going to go from moles of our element to our mole ratios. So we're going to divide by the smallest number of moles. So our smallest number comes from manganese. So we're going to divide all of our values by 0.6329. And we want to keep some of our decimals. Okay, and this is where you're going to approximate a little bit. I would approximate to the nearest quarter, or sometimes a third is a more convenient number to round to. But basically for this first one, this is going to be essentially 1. For manganese, we're dividing by the same number, so that is 1. When you calculate this out, okay, your calculator is going to give something like this. Okay, and we're going to approximate. We're going to say, okay, that's about 4. Okay. If this were, say, 4.2, I would probably round that to 4.25. Then you're going to have to multiply each of your ratios by 4 to get a whole number here. Okay. However, in this example, we have whole numbers, so we don't have to multiply them by any factor. So our final answer then, our empirical formula, is going to be K, 1, but we don't need the 1. Mn, again 1. And O, 4. So this is our empirical formula for this compound having these mass percentages.